All right. Welcome to our weekly broadcast. I'm Danielle Smith, president of Alberta Enterprise Group. I want to just sort of frame out for you why we're doing these sessions. And part of it is that I am having such fascinating conversations with our members that I figure, why should I be the only one who has all this incredible knowledge? Why don't I try to make sure that you know it as well? Because we've got a lot of problems that we need to solve in Alberta, but I would say that we have entrepreneurs who are up to the challenge and solving them. That's one reason. The other reason, and I had somebody give me a bit of a rough ride asking me about why it is I fully embrace the Paris Accord commitments. And I think we just need to have a bit of a reality check about where we're at from a political point of view. From a political point of view, the Supreme Court has ruled on the issue of carbon pricing. And it doesn't matter whether or not we end up with a federal liberal government or a federal conservative government. We're going to have a carbon price at the federal level. And so the choice is pretty stark for Alberta, is that we either take control of our own destiny and carbon price and figure out a carbon market and figure out a way to carbon neutrality from a provincial-led perspective and an entrepreneurial-led perspective, or we allow it to be in the hands of Ottawa. So as you probably know, I'm always on the side of doing things closer to home, especially with the talent and expertise that we have. So that would be, I hope that you take these conversations that we're having in that spirit. The other thing I'd say is that it seems to me that our business owners are doing a tremendous amount to address the issue of carbon neutrality. And there seems to be some sense that there's some hesitance or reluctance to move down this path. And I think that couldn't be further from the truth. So I wanted you to hear with your own ears some of the stories and some of the things that our business owners are doing to try to address this issue. The other thing I'd say is when I interviewed Cody Battershill, who I used to love interviewing as a part of Canada Action, one of the things that he said that really stuck with me was that you cannot make a wind turbine with a wind turbine. And let me just flesh that out a little bit for what that actually means. When you think about how you get wind power, well, one component is wind. Sure, that's zero emissions, but it's also the transportation to get it to the site. And when I spoke with one of our members who's involved in moving wind turbines to site, it was 1,500 truck transport loads that he had to take to establish a wind farm. The other component, obviously, of wind turbines is steel. Another major component of wind turbines is the concrete to embed it in place. So as much as we talk about zero emissions and renewable energy, you will not have zero emissions wind until you have zero emissions transportation, zero emissions steel, and zero emissions concrete. And so with that in mind, my guest today, we've already talked about the issue of hydrogen, which I think is really important from the perspective not only of creating a pathway for wind and solar to store energy, because batteries have their own complications, but if they can store energy in the form of hydrogen, that allows them to deliver seamless energy to the grid. But in addition to that, it also allows for truck transport to have some of the heavy truck transport be powered potentially in the future by hydrogen fuel cells, which is currently in creation. So I think we've dealt with that one piece. We will deal with steel in a future show, but let's deal today with cement and concrete. And I've got two experts from one of our member companies, Lehigh Hansen, who are generously agreeing to join us with their time to explain a little bit about what it is that they do. Ignacio Carriega is the technical marketing manager for the cement division, and Trevor Panis is a general manager for the Northern Alberta division for their concrete. Now, thank you both for joining me today. And I want to maybe start off with cement, because I'm glad I'm not the only one who has this problem. I went online and I found out that cement and concrete are often used interchangeably, and they are not the same thing. So let me begin with Ignacio, who is the expert on cement, and tell us first of all, why do we have that confusion? Why do we assume that they're both the same thing? Is that just laziness and the fact that many of us don't know your industry as well as we should, or is there some reason why we end up using those terms interchangeably?
Yes, and believe me, first I just want to confirm you can hear me okay?
Sure can.
Okay, perfect.
I can't hear.
You know what? I was going to begin by actually clarifying that if you didn't, so I'm glad you did. It's used interchangeably, and you will often hear, I'm going to be walking on a cement sidewalk, and there's not such thing. As we know, cement is just one of the raw materials to make concrete. And the best way to explain this so it could be understood by public in general is probably an analogy that illustrates the difference between cement and concrete, is to think cement as to flour and concrete as to the bread, meaning that cement is just one ingredient to make a final product called concrete. And I think that way will be easier to understand. And please, when you refer to a ready-mix concrete truck rolling on the road, don't call it cement truck. That's a ready-mix concrete truck. Hope that helps.
It certainly does. Okay, so let's continue on talking a bit about how cement is created. I'll bring Trevor in a minute when we get into baking the bread, to use your analogy. But give us the background so that we understand just how carbon intense the creation of cement is.
For sure. No, it's something that we're very passionate about. Obviously, as you know, the spotlight is on cement because it's very carbon intensive. But however, it also presents an opportunity. And just for people to understand, why is cement such a big spotlight when it comes to greenhouse gases and carbon emissions, is that cement is considered to be a hard to abate sector. And what does that mean is from the emissions created by cement, 1/3 of those emissions come from the combustion emissions that is used to heat the kiln, because obviously to make cement, you need to use a long heat kilns, and kilns are going up to 1500 degrees Celsius. So it's quite a high temperature, and the fuel you use, meaning we used to use coal to burn to get to those temperatures. Now we use natural gas, and now we're also investigating low carbon alternative fuels. These alternative low carbon fuels are ones that you can burn and reduce those emissions. So for instance, if we were to reduce that 1/3 of emissions, it would still leave us with 2/3. And the 2/3 comes from the actual calcination process, which is the chemical process of when you start burning and grinding the calcium limestone, right? All the calcium carbonate, which is the calcium, to make clinker, which is a intermediate product before you get to the cement. So that's the problem of our industry. It's the 2/3 of the calcination process, which is hard to abate. So and that's where we have to bring other technologies to remove that. And one example is the carbon capture, for instance.
Let's talk about the third that you've used in switching out coal to natural gas. Was there any deterioration in the energy efficiency or any increase in cost associated with doing that? Or did it make economic sense to do it?
Well, it depends. And as you know, the price of natural gas is very volatile. At one point, it was more economical to use coal. But it goes back and forth. It depends where the market is. Natural gas is obviously a little more expensive, but it fluctuates. Now that we're bringing alternative low carbon fuels, those could depend on which one you're talking about. It could be a cost premium, but at the end of the day, we're definitely committed to the reduction of emissions, and we need to make sure that that's front and center. Not only to us, but all the way to our board of directors in Heidelberg. Our ESG commitment is to reduce emissions, and we have targets set out, and the motivations that we have are very tangible for us. To the point, quite frankly, Danielle, that the carbon neutrality roadmap that we have has been put forth top down throughout every country in our association, and everyone has targets to meet on a yearly basis. And interesting enough, those targets will be tied to your variable pay. So
wow.
So that speaks highly of walking the talk. We are committed, and it shows, because if we're not committed, it will definitely impact on your variable pay.
Okay, so again, for those who aren't as familiar with your industry, I need you to back up and walk me through a couple of things. So when you talk about alternative fuels, If you're not going to use natural gas, what are you talking about? I guess the first thing that comes to my mind is hydrogen, but I don't know if we're far advanced down that road. I'd have a hard time believing you could get the power that you need out of solar and wind. Maybe I'm wrong, and you'll correct me here. But what would be the alternative fuels that would be carbon neutral or carbon free?
There are waste products, for instance, wood, construction debris, and anything that you can burn to get to the calorific value that we need it, without the impact of creating the emissions or greenhouse gas emissions. So there's a whole host of different options, and we're currently involved with Emissions Reductions Alberta to create those alternatives and make sure that we are implementing this program. It's on the works right now. We are not currently burning. The other plants around the world are. In fact, there's one plant in the UK who's actually doing a pilot program on something you just mentioned, is to burn hydrogen. And it's still very preliminary, but technology is evolving at a rapid pace these days.
Okay, you're going to have to walk me through this other part that's a lot more complicated, where you say that you have to try to find a way to reduce 2/3 of your emissions there. What is the actual problem with trying to find an alternative?
Right now, the chemistry process prevents you for stopping the carbonation, meaning the release of CO2 on the chemical process. So when you start calcining, it is inevitable that CO2 will be emitted. It's part of the chemistry process. So the off gas, the flue gas that comes from the stack on the kilns, contain 15 to 20% CO2, a lot of hydrogen and other impurities. We do have control on those impurities. We are meeting the standards. However, the CO2 is vented together with the flue gas. And what we're trying to do is, the other technologies will be to capture the flue gas, separate the CO2, and then just once you have the CO2 fully captured and separated from hydrogen and other particulates, then you can have the CO2 compressed into a liquid and then put into a pipe and take it to a sequestration site.
Okay, how close are you on that part of the program?
Well, I'm glad you asked, Danielle, because in fact, as of November 2019, we are very proud and honored to have an announcement made by our president, Jörg Nixdorf, which announced that we will be starting a feasibility study of carbon capture in Edmonton in the cement plant. And it's going to be first in North America, and sometimes at a large scale, it would be first around the world. Because this will be the first cement plant that will be capturing large scale, and by large scale, we understand it to be over 500,000 tons of CO2 a year. There are other cement plants in our group that are currently working on this similar carbon capture projects. However, not to this scale. This will be the first large scale.
That's amazing. Okay, so now it sounds like you're doing all the work in your division, Ignacio. So we're going to find out what how the carbon footprint changes once we start talking about concrete. We were just talking about cement. So Trevor Panis is head of the Northern Division for concrete for Lehigh Hansen. So Trevor, just building on what Ignacio was saying, tell us the difference then of what components you add to cement to make concrete.
Sure. Well, I like to start off these conversations by saying that the elephant in the room is that cement and concrete production are they represent about 7% of worldwide greenhouse gas emissions. So they're a big number, and it's on us as an industry to find ways to reduce those. So, I always start off by saying, hey, yeah, it is a big number, but that's why we're so important, is because we have there's big levers that we can pull to reduce global emissions as a result. So when you actually take the cement that Ignacio and his group produce and send it to our manufacturing facilities, where we combine it with other ingredients to create the concrete that we walk on, that builds our houses and our high rises and our roads and all those other things. When we look at the carbon intensity of a cubic meter of concrete, which is that's kind of the unit of measure that we use for concrete production. About 75 to 80% of the carbon intensity, the embodied carbon of a cubic meter of concrete, comes from the cement, the binder or the clinker, the Portland cement that's in that concrete. So if we can address that 75 to 80%, we can make some pretty significant contributions to lowering the overall carbon intensity of our building materials. And so what I do in my group and with my peers around Canada and North America is I'm part of a Lehigh Hansen's low carbon concrete teams, both the NAM and Canadian committees. And we're working towards pulling various levers to reduce that 75% down. The remainder of it comes from things like sand and gravel production and transportation, because that's one of the other main raw components, as well as transportation of other things, as well as transportation of product out. So we're really focused on addressing that call it 3/4 that comes from the cement. So things that I can do, some of the big levers that we pull is looking for alternative binders and getting the most strength and use out of alternative binders. So things like fly ashes, other what we call SCMs or supplementary cementing materials, whether that's slag, metakaolins, silica fumes. There's a variety of different items that variety of different materials that we can use to replace cement in the concrete mixes without negatively impacting performance. But to do that, it takes quite advanced engineering. It takes a complete understanding of the materials in your mix, and that's everything from the sand and gravel to the cement, to the SCM that you're using, to the chemical admixtures that we use to control certain characteristics of the mix. So one of the things that my group has been challenged to do is how do we reduce the amount of high carbon cement that's in a concrete mix while still getting the same end use performance. And so big levers that we pull, fly ash and SCM usage, especially here in the prairies, we have an abundance of fly ashes. Ignacio can talk a little bit about the future of that, because we obviously know that fly ash is a byproduct of coal-fired electrical production, and that's not going to be what I would call like virgin fly ash will not be available to us for probably beyond this decade, as most of these burners switch over to natural gas. But Ignacio's division has actually come up with a new product called EcoSem, which is a low carbon cement. It's got about, Ignacio, correct me if I'm wrong, but probably about 25% less. The EPD would show it's about 25% less carbon intensive than your typical standard, what we call general use clinker. And that cement has been specifically designed to be able to transition between raw virgin fly ash that we get now and recycled landfilled ash that has been essentially landfilled in Alberta since we started coal-fired electrical production. And so, the process to reclaim that is extensive and technical, but we've designed this cement in order to allow us to transition off of existing fly ash sources to landfilled sources as we go forward. And just by using fly ashes, we can usually reduce that 75% proportion that I talked about in concrete. We can usually reduce that by about 25 to 30%. So now you're talking about an overall reduction somewhere in the neighborhood of 20 to 25% in the carbon intensity. And that's just one of the levers. Yeah.
I'm going to go back to Ignacio in a minute because I want to understand what some of the replacements are on fly ash. But I think you need to maybe expand that out a bit so that we understand. I was talking to a friend of mine in the natural gas business and telling him about this problem that we have with fly ash when we close down our coal plants. He said, "Are you telling me we're going to be sending LNG to China and then they're going to be shipping us back fly ash from their existing coal plants for us to be able to make concrete?" And I thought, gosh, I sure hope that's not the case. But talk to me, if you would, Trevor, about why it is that fly ash is such an important part of the concrete mixture. Because I'm wondering, is that just because of the conditions that we operate in, that it needs to be able to withstand extreme heat and cold, or is that just a regular component of any concrete that you need to have fly ash?
No, it's definitely not a regular component of any concrete. So a couple of things. One, it's economics. Although those economics are starting to change as fly ash becomes more scarce. But the idea with fly ash is it's an SCM that in the presence of the other materials in a concrete mix will actually start to form its own crystalline matrix. So when concrete goes from just a wet gray liquid or semi-liquid into a hardened structure, it undergoes a hydration process that basically it forms a crystalline matrix. That's how it gets its strength, right? And fly ash by itself won't react, but in the presence of the other chemicals in a concrete matrix, it will react almost as it, and it becomes a cement replacement. So economics are one part of it, but certainly technical considerations are a big one too. Fly ash makes things more durable to things like salts and chlorides that we find on the road. Here in Alberta, we have a lot of sulfate conditions in our soils, and that can be, it can degrade concrete over time. And by adding fly ash to the concrete matrix, it makes it less permeable. And so it keeps water infiltration and salt and sulfate infiltration out as well. It also has other applications too to make it, it'll make the concrete mix, it acts as a great water reducer, so it makes it more flowable. We place a lot of our concrete by concrete pump. Fly ash is a great, it makes things a lot more pumpable. So it has a variety of technical and economic uses for us.
And I just want to make sure that I understand what you're saying is that you're now having to go back to landfill sites where there was sort of a lesser quality of ash from coal plants that you're now reclaiming. Is that?
No, we're not there yet. We still have access to virgin fly ash as it comes out of these plants. And Ignacio, you can jump in if you want to talk a little bit more about the timelines. But what we have done is we've created a new Ignacio's group has created a new cement called EcoSem that incorporates fly ash directly into the cement production. Instead of traditionally, you would combine cement and Portland cement clinker at the concrete plant into your mixture. But Ignacio's group has developed a pre-blended cement that incorporates fly ash. And one of the reasons we've done this, and one of the benefits is we're going to be able to use alternative fly ash sources as part of that production more easily in the future.
Beautiful. Now I understand. I'm glad we went through the difference between cement and concrete so that we can go back to talking about this new formulation of cement. So tell us a little bit about that, if you could, Ignacio. I hope that you were able to hear everything Trevor said because we were having problems with our. Okay, good.
Yes.
So talk to me a little bit then about how you're putting this together, because I am quite interested. I do know that there are some companies, like Carbon Upcycling is one company, where they're taking sequestered carbon dioxide and turning it into a fly ash product. And so I'm wondering if there's some way that you're going to ultimately be able to use so if you've got this waste stream of CO2 that you're trying to find a solution for, I'm wondering if maybe you can turn it into a product that you actually need for a component of the cement. Am I onto something here, or is there a lot more to it than that?
Absolutely, Danielle. You should start patenting your concepts because they're certainly something that a lot of technologies like carbon upcycling and others are investing into. The one thing that I would say is going back to the EcoSem, EcoSem Plus. Yes, we are using a fly ash currently, fresh or production ash, as Trevor alluded to. In the future, we are going to have to rely on landfilled or harvested ash from landfills. And the landfill ash is no lesser of a product. It wasn't landfill because it was a less quality. It was just the fact that the plants used to have so much byproduct of ash that even if the concrete market were to buy all the demand, they were still left over. And there's decades of fly ash that have been landfilled. So there is plenty of volume available. Obviously, there needs to be a beneficiating process that makes sure that it meets the spec. Obviously, when we do that, it has to meet this fly ash spec. So it will be done accordingly. It is not in place currently, but something that the industry is looking at. The other comment you had around using of CO2, here you put 2 + 2 perfectly because you have, here's Lehigh wanting to capture CO2, and they need to get rid of that CO2. And here's other technologies that want to or need CO2 as feed to create a value-added product. The one thing that limits us is scalability, and that's very important to know, because think about it as our CO2 will be coming in a, call it 6-inch pipe. And the utilization opportunities that we are seeing, like carbon upcycling and others, might require just enough volume to feed a straw. Oh. So we have too much of volume coming in to get rid of it on just one technology. And it's very difficult for us to look at every single opportunity and have thousands of straws coming out of our plant versus just one pipeline. So we're prioritizing based on how we can get rid of it 100% all in one shot first, and then potentially we could develop research opportunities of proof of concepts, small streamlines from our CO2 capture to develop opportunities and to understand what else we can do, because we can certainly create the CO2 to be used in applications where we actually close the circular economy loop by injecting CO2 in concrete, by using to cure concrete, or by using to enhance fly ash, like what carbon upcycling is doing.
So if I'm hearing you, it's sort of a two-step process. So if you capture it first, then the first plan is storing it in liquid form until you can find potential value-added products that you'd be able to use it for.
Yes, and when I say store it, it's permanently sequestration. There's deep saline aquifers available close to our facilities in and around Alberta. Quite frankly, there's a lot of locations. So that would be the first goal, to get to make sure that it's permanently sequestered, and something that publicly typically is afraid of. But however, this is, I'm not sure if people know, but it has been already done for decades in Alberta of using sequestration solutions in deep saline aquifers. It goes, anywhere between 3 to 4 or 5 kilometers deep, and it passes through many impermeable layers. So that guarantees you the fact that when you're injecting it, nothing's coming back up. And there's methods, they called MMV, monitoring, measuring, and verification process and protocols that government put in place to make sure that that CO2 is monitored at different levels, subgrade levels, and also at the surface area levels, to make sure that none of the CO2 has the ability to surge back up.
Okay, one more thing I want to ask you before I leave the issue of reclaiming fly ash from landfill sites is, you're a large company. Is that an option that's only available to you because you've got your own sites, or is that something that anyone in the cement manufacturing or concrete manufacturing business would be able to access?
Well, it's basically in the hands of the power producers. That's where their landfills sit. So it'll be up to them to create a beneficiating process and have this harvested ash available.
Do they know that it's going to be in demand in 10 years' time? I guess you must have already told them.
Oh yeah, no, they're already commercializing the ash, the fresh ash, and obviously they know the market dynamics and they know the demand, so they're certainly aware of it.
Okay, let me go back to Trevor. And I just want to, I find that this conversation so fascinating because things are always so much more complex than when we have the environmental conversation. And I think what has happened is it's become very polarized, where we're seeing a push to get to zero or net zero very quickly. And I think the public is concerned that, are we even going to be able to do it? I want to get a gauge of your level of confidence, and I'll start with Trevor and then I'll go to Ignacio. But what is your level of confidence that this net zero target by 2050 is achievable within your industry?
Well, Danielle, I can speak from just the area responsibility that I have, and so in addition to things like fly ashes and SCMs, there's various ways that that my engineering group pursues lower carbon concretes. Really, at the end of it, it's our goal to meet the performance specifications that we're given And in my vernacular, that's 30 MPa or 35 MPa. That's just a unit of strength. We're given in specifications a unit of strength we've got to meet, and it's my engineering team's goal to meet that with the lowest possible carbon footprint. So we are looking at getting as much, bang for your buck, if you want to use that term, out of every kilogram of cement that Ignacio would supply to our group, and our cement group supplies us. So if we can, just going back to my example, where I said that cement makes up 3/4 of the carbon footprint of concrete, if we can get the same performance out of using half the cement through a combination of SCMs, or we do a lot of advanced engineering with different chemical admixtures now as well. And those chemical admixtures are things like water reducers and strength enhancers and high performance, what we call like polycarboxylate water reducers, that allow us to achieve much higher strengths without having to add more cement. So when we baseline ourselves versus what's called the CRMCA, or the Canadian Ready Mix Concrete Association industry benchmarks, because CRMCA publishes what the industry benchmark CO2 equivalent of different mix performances is. And when we've benchmarked our progress against those levels over the last 4.5 to 5 years, we've seen it come down from a point where we were pretty much at or just slightly below industry average to now we're producing concrete mixes a lot of the time that are 40 to 60% below the GWP, or global warming potential, that we see published as an industry average. So in 4.5 years, locally, and with the support of the global R&D division that Lehigh Hansen, as part of Heidelberg, has access to, we've been able to reduce that carbon intensity by about 40 to 60%, depending on the application. So over a fairly short period of time, and enough so that, and when you combine it globally, that Lehigh Hansen and Heidelberg have what we call a Vision 2030 and a Vision 2050. And Vision 2030 was to get our carbon intensity down by 30% relative to a 1990 baseline. We're well on pace to achieve that goal 5 years ahead of schedule. So it's, as Ignacio said earlier, everybody in the company is now incentivized towards hitting that goal by 2025. And so that's just my group's performance is down by about that 50%, give or take, over the last 4.5 years since we really started focusing on this. So now to put that in context of how do we get there by 2050, the other 50%, because we've picked the lower hanging fruit, right? And so it now becomes a bit more challenging. But it relates back into further engineering at the mix design level, and the mix engineering level, because it all looks gray, but it's actually a fairly complicated manufacturing and production process. And then it kind of goes back to Ignacio's group as to, can we continue to, or can we get some carbon capture and utilization? Because as long as we're using any clinker, any cement at all, we're going to have to deal with just the chemical off-gassing of that, no matter how we produce this, no matter what energy or fuel we use to produce the cement. And so we've got kind of that 50%. I think the concrete technology part of it can probably get us another 15 to 25%, where, we might be able to, as a concrete specific producer, get down to like a 65, a 65 to 75% reduction. And then it's going to be up to the fellows and to the folks in Ignacio's group to get that the rest of the way there.
Oh my goodness. So it sounds to me like everybody in the company's variable bonus depends on your work, Ignacio. So everybody wants you to be successful. So what do you think about those targets? Are they, because I'm just trying to put it into context, because I think people are really fearful, since a lot of the discussion around CO2 emissions have been, we have to stop doing that. We have to keep it in the ground. We can't use fossil fuels anymore. And it strikes me that through innovation, carbon capture, and finding useful uses for end products, it sounds to me like there's another path forward. And so the question will be, will it be enough? Can we meet the 2050 net zero goals with the kind of work you're doing? What do you think? Is it achievable?
Well, yes. And before talking about the level of ambition that this presents, I think it's important to relay that people might ask, how do they make these targets? Are they just pulling these targets out of the air? It's talk is easy. I can say I'll get carbon neutrality in X years, but the way we've approached this, Danielle, is quite frankly very scientific. In fact, back in 2019, we presented our targets to an association or organization called Science-Based Targets, and they actually approve our targets being technically and scientifically approved. That means that they're achievable. So it's not our wish. It's not a wish list that we're presenting them. It's scientifically proven how we're going to achieve our reductions, 30% reductions by 2025, and then our carbon neutrality by 2050. And something that I will add to that is the science-based target initiative not only approves it, but it rates your targets and the way you're going to reduce them. And we're happy to and very honored to share that we were rated one of the highest rated companies, especially in the cement industry, as an A, which is one of the highest level we can achieve. And this was done back in 2019. So now that we have our science-based targets approved, now here comes the challenge: is how do we implement those actions? Trevor alluded to some perfect examples, but the one thing that we had to start, Danielle, was education. It's almost culturally accepted or not, the fact that a lot of markets had no really involvement in sustainability initiatives. They just referred to them as flavor of the day, and they thought that it was coming and it was going to go. But boy, they were wrong. This is here to stay. And in fact, just to talk about the bonus structure is a clear example. So what we started is with education, making sure that everyone's on board. And the second thing is we started creating what we called product transparency. And because there's no way you can improve if you don't measure. Perfect examples: if you go to a hockey game and you're late to the game and there's no scoreboard, how do you know who's winning or losing without a scoreboard? So what we did is created a scoreboard, and that scoreboard comes in a way of what we called environmental product declarations, which are an acronym for EPDs. You have to excuse me, we're full of acronyms on this in our
You're
industry.
pretty good at being able to spell them out, so that's good.
Right.
So this is environmental product declarations?
Yeah, and the best way to understand what this does is when you go to a grocery and you want to buy a cereal and you're conscious of, you're healthy conscious, first thing you look at is your nutrition label. And you look at calories, you look at, contents, et cetera, sugars. So no different than a nutrition label is an EPD. So an EPD tells you the global warming potential of your building product measured in kilograms of CO2 equivalency per ton of cement, if you're looking at an EPD for cement, or kilograms of CO2 equivalent per cubic meter of concrete, if you're looking at concrete. So now that we have the vehicle and the tool to show people openly and transparently what our product has or has not, then you can start creating a baseline, which will help you then start putting together your targets of reduction. So that's where we are. We've already embarked the transparency journey. We are the first cement player in cement plant in Edmonton to have our EPDs done with the latest product category rule. And product category rule is just basically the recipe to create an EPD. And every 5 years they renew it. So we were the first one to create the cement EPDs for all of our products in Edmonton. And now that we have those EPDs, we're working towards reduction in meeting those targets.
So just so I'm clear and understanding how they're used, I mean, if I'm a consumer, I'm not sure, do you only provide to industrial and commercial sites, or do you provide to just regular buyers if you wanted to go in and you needed to get some cement?
That's a great question. It's public domain, first of all. These are published, and there's what we call a program operator. And these program operators are basically doing the job of publishing and promoting those EPDs publicly so that consultants, architects, designers, owners, developers, city officials, government officials have access to it. So this is a big database where anybody can search for an EPD, any type of building material.
I guess the thing I'm almost thinking like light, medium, dark, or green, yellow, red, like different sort of labels saying, hey, this is your most environmentally friendly and the least amount of CO2 produced per kilogram or per I think I'm trying to get the other measure, cubic meter. And then this is the one that's the traditional way. Is that kind of essentially how it is? Is it coded that way?
It is if you're just looking to buy and compare between similar products. But you can't compare, for instance, an EPD for cement with an EPD for steel, because they're different measures, they're different, and they might serve different purposes. So what you do is, I mean, the industry is coming to a point where, similar to when you do your cost estimate of a building, then you add up everything that, your foundation cost, your structural cost, your finishing cost, and then you come up with a total cost. And then that divided by the square footage, you have a price per square footage of the building. Similarly, now what we call carbon accounting, you do the estimate of the building and add everything that it took to make that building in terms of global warming potential. And at the end of that exercise, your building is going to have our carbon intensity per square foot or per square meter. At that point, that's where you say, my target was to reduce X or Y kilograms of CO2 per square meter. And I wonder what are my levers that I can use to reduce that. And then you start looking at specific materials and say, I wonder if I use this EPD or this product with this other product that has lower EPD, then my whole building would have a better result. And that's where you start making those decisions. But it's funny, we're having a transition from not only cost, but also do carbon accounting. For procurement purposes, people are going to make decisions not only based on cost, but based on global warming potential. And it's coming.
Well, that's the interesting thing. You seem like you're on the cutting edge and maybe leading the rest of your industry on this. So let me bring it over to Trevor, because I thought it was interesting that Ignacio talked about, do we have this for concrete versus steel? Because I guess that's kind of the trade-off, isn't it? I mean, you tell me a little bit about how your business works and where somebody might make a decision to go concrete versus steel, just so that we understand how some of those decisions get made.
Sure. So when we're looking at different building materials, whether that's concrete, wood, steel, plastics, prefabricated plastic modules, things like that, the decision is usually one from design and economics being both the cost of the material, but also the schedule cost and labor install cost. So it's, right now, a lot of it is driven by sometimes comfort of the designers with various materials. There's designers that are more comfortable with steel or comfortable with concrete. And it just depends on what type of building that you're trying to put up, right? Whether you're building a house, a bridge, a sky rise, or some sidewalks, right? So that's kind of what drives the decision right now. And I think what Ignacio is talking about, and I've had a few meetings with some of the larger, public general contractors that I'm sure you've had on this show a few times too. And around the concept that Ignacio is bringing up is that the day is coming fairly quickly, and they're trying to get ahead of it, where they're not only going to get a cost budget and say, hey, you've got to build this school for $10 million. It's going to be, you've got to build this school for $10 million. And in the 50-year lifespan of this school, the total global warming potential between the embodied concrete of the construction materials and the operational, the embodied emissions of the construction materials and the operational emissions from heating and cooling, et cetera, have to fall below 10,000 tons of CO2. And then at that point, the EPDs that the material suppliers like myself would provide, the general contractors are going to have to do the math on that the same way that they do on all their sub trades to cost out a building. They're going to say, how do I get under 10,000 tons of CO2 equivalent for a 50-year lifespan and still keep it under $10 million? And maybe that means spending more money on concrete for lower carbon concrete, because that's the most cost-effective way to get underneath that 10,000 tons. Or maybe it means using triple glazed windows instead of double, or maybe it means putting in a different a high efficiency HVAC system so that the operational emissions are lower. So really, there's an economic driver for folks like myself to make sure that we're prepared to have those conversations and that we can come to the table with cost-effective, low carbon concrete options.
Well, let me go back to Ignacio, because this is sort of a new concept for me. I mean, I've been accustomed to thinking of green buildings and LEED standards in terms of what Trevor was just saying, the operational side. I hadn't really considered it in the construction materials. So how close are we to that being a reality? Do you think we'll likely see that in some of the large government procurement contracts first, or do you think industry will lead that, or is it already happening in other parts of the world?
It's definitely already happening, and I'm happy to share some information regarding that. First of all, the evolution, you mentioned LEED, and that's the first term people refer to when they talk about green buildings. And LEED is, Canada Green Building Council, or USGBC, US Green Building Council. It's a rating system based on credits that you get, and those credits mostly are driven by operational emissions, energy use, water use, and that, et cetera, et cetera. It really doesn't account for anything or much related to the embodied carbon. And so let me define what embodied carbon is. Trevor alluded to it. Embodied carbon is all the carbon emissions related to the extraction, manufacturing, transportation, and construction of a building. So the building materials and the actual construction process of a building. So that's what we call the embodied carbon. And obviously cement and concrete are one of the most carbon intensive materials on the embodied carbon. In fact, 11% of the global emissions are driven by construction and their building materials, of which 7 to 8% come from cement. So we're definitely on the spotlight, but it also is an opportunity for us to address it, and we're doing so. So the other question you were asking was, have we seen policies around this, and who's driving this initiative? It's certainly private investments, the ESG community of, say, the Fortune 500 companies, the likes of Amazon's, the Facebooks, and the big corporations which have the big ESG responsibility reports. They are creating voluntary specifications on their project to first ask for building products that have EPDs, and also ask for lower embodied carbon footprint materials. But closely now, we're seeing some city officials and in both Canada and the United States. For example, in Vancouver, we've seen as of late last year the announcement of the CEAP, the Climate Emergency Action Plan, where they're actually targeting 6 levers, and one of those 6 levers is embodied carbon. And they are asking, as of 2021, so this year, that you need to present a performance spec or performance solution driving your embodied carbon reduction by at least 10%. So it's interesting to note that this is a performance specification. What does that mean? That they're telling you need to reduce by 10%. How you do it, it's up to you. You're the expert. But they're not being prescriptive in saying you're going to use X and Y cement and concrete to achieve it. They're allowing you to know how to do it, as long as you can achieve the performance of the reduction, which is the 10%.
Amazing. Let me go back to Trevor then, because you'd identified the ways in which people normally make decisions about what type of product they're going to use in construction. So when you're stacking everything up, wood, plastic, cement, concrete and steel, do you feel like concrete will then have the advantage in that calculation? Or do you feel like maybe your company in particular will have the advantage in that calculation? I'm just trying to think of how the industry is going to change once this embodied carbon idea becomes part of the norm for construction. What do you see happening?
Yeah, well, we certainly hope to have the advantage. That's one of the reasons why we've done the work. I mean, it's not just socially and environmentally responsible. There's also some economic drivers behind it. In order for us to remain competitive in a low carbon concrete, in a low carbon economy, we have to be leaders in understanding how we can get there. So definitely compared to other concrete producers, our company wants to set ourselves out in front as being the experts and with the lowest carbon options. But we also need to be mindful of the competitive products that are out there, whether that's wood or steel or plastics. We have to be able to compete in terms of building cost and performance and carbon intensity versus them as well. And we've come a long ways towards doing that. There's an argument to be made that operationally, concrete is a great building solution compared to wood, just because of the low maintenance requirements, the quality, the indoor air quality, the durability of the structure, the lifespan of the structure. I mean, it's no good to build something that's really low carbon if it lasts for 50 years. If you could build with a little bit more and have it last 100 years, right? So you've got to look at total life cycle. And it's also worth pointing out that we're doing a lot of work right now quantifying the amount of lifetime carbon absorption of concrete that's in situ, because concrete acts as a carbon sink throughout its entire lifespan. And there's also the cradle to grave, or we call it gate to grave theory of construction, where it's not just about the embodied carbon of the materials and the operational carbon of heating and cooling that building for its lifespan, but what about the demolition afterwards? And things like concrete can be recycled, recarbonated, and used again, whereas some competing products like wood are landfilled, they rot, and they give off CO2 emissions as they do that, right? So when you're really looking at the full cost accounting, we're confident that we're very close to being carbon equivalent to some of the leading products out there right now, and we're trying to go the rest of the way.
It's amazing. Okay, let me then talk about, because I'll have those in the construction industry listening to this thinking, oh my gosh, how much more is this going to cost me? And I'm wondering on that, Ignacio, I guess there always is an initial cost when you start moving into a new product, but when it becomes the norm, especially if you can start monetizing some of those streams, I don't know, is there a future where it would actually bring construction materials costs down, or do you anticipate that we're just going to have to accept that because we're moving in this direction, we're going to see a premium on construction costs?
Well, I would say it's first, it's hard to know. It's almost having a crystal ball of what's going to happen in the future. But just if you reflect on any new technologies that come on board, there's the first mover advantage, but that also comes with a little bit of a premium. But as everything, new technologies and advancement allows those premiums to go away, because then you're becoming more efficient. Any new technology at first has a little bit of a premium, but the user, the volume, and the demand for it allows technology to improve and costs to come down in the future. And quite frankly, there's the other thing is, we need to ask ourselves the question, how expensive would it be not to have a low carbon solution? That's something that is worth thinking about. Climate change is real. It's happening now. And the fact that we need to come up with a solution on the embodied carbon especially is important, because it's time sensitive. Once you build that project or the building or the bridge, that embodied carbon has already been released to the atmosphere. The operational emissions happen through the life of the project. When you start creating renewable energy, for instance, you can manipulate the life of the project to reduce your operational emissions. But you can't do anything to go back and change the embodied carbon. That's done. So that's why there's such a big focus on the embodied carbon these days, because it's time sensitive, and we need to do something sooner rather than later. Okay. And one thing that I will add when you speak to other materials, and it's a fun fact. Today, second only to water, I'm not sure if you knew this, concrete is the most consumed commodity in the world.
I did
Think
not
about
know that. No, no. Tell me why is that? Tell me just so that for all the reasons why people might not automatically think, oh yeah, that's where you use concrete. Give me some examples of why it is so
well,
common.
just think about since you got up this morning to where you are today. How many times were you exposed to concrete? I mean, you walked out your driveway. There you go. It's not cement. It's concrete. You go to sidewalk. That's concrete. You got the roads, bridges, buildings. Anything you touch, most likely will have concrete throughout your day. And that's why we say, today, only second to water, that concrete is the most consumed commodity. And as much as concrete, twice as much concrete is used in construction as all other building materials combined. Now, obviously, building materials have a place, but you will, one thing for sure, it doesn't matter what your structure of the building is, you will still need a foundation, and that foundation, up to last time I've heard, it's always been used concrete. Concrete is always being used in the foundations for a simple reason: it's durable. Trevor alluded that it has to resist sulfate conditions. It has to resist, frost, or freeze and thaw, et cetera, et cetera. So it's very resilient and durable product and economical. Hence the vast use of it.
Well, and it makes sense then that you take so seriously the obligation to try to reduce carbon emissions, because if there isn't really a very good replacement for that construction material, then let me ask the other side of this, because I think people get frustrated that it seems like all we ever hear when we're talking about CO2 is costs. And do you get any benefit for being a leader on this? Is there a way to generate carbon credits for the fact that you're capturing this carbon dioxide into the building materials? Maybe I'll start with Trevor, and you can tell me if there's a benefit side or if it really is just appearing like an avoidance of costs, because we know that the CO2 price is going to head up to $170 per ton. Is there any other way of doing that calculation?
In terms of credits, that's more on Ignacio's side of things. So I maybe let him answer that when it comes to emission reduction credits.
Okay, I'll ask him that, but why don't you pile on and talk about how important concrete is?
Sure, I can talk a little bit about that. I mean, ultimately, there's initial engineering and fixed upfront cost to designing any new technology. To build the first iPhone probably costs $500 million, but to produce the second one costs $10, right? And it's not different for any industry. So as we develop these products, there's a large upfront cost. So as my group develops low carbon and ultra low carbon concretes, certainly those are designed initially with a reasonable cost premium in mind to sell to ecologically sensitive end users, whether it's private citizens or public procurement. But very, very reasonable. And, we're talking about percents, not, single digit percents. We're not talking about double digit percent cost differences. As time goes on, you're going to see those cost differences shrink between traditional carbon intensive concretes and low carbon concretes. Right now there certainly is a reasonable premium for those. And are we able to realize that in the market? Yeah, we are. I mean, consumers are starting to ask these questions. They're willing to spend a reasonable amount more to do their part for the environment and to reduce emissions. And so right now we certainly are able to recover some of that. And I think as time goes on, we're going to be in a position to sell more concrete to end users as they realize that we are the best way to achieve their building solutions.
All right. So let me put that to you, Ignacio, then the question about carbon credits, because it does strike me that if you're capturing CO2 and embedding it permanently into a material or permanently underground, it strikes me that there should be some kind of offset that you get. And it seems like we're really good at charging the taxes when you emit, but not as good at giving the benefit when you go the other way. Has that been corrected, or is there more that needs to be done?
Well, no, I'm happy to say that Canada is fairly advanced on that, and similar Alberta as well. Alberta has what we call the TIER program, which is the Technology Innovation for Reductions. And what it does, it provides a benchmark for every industry. So there's a tier industry benchmark for cement industry, separate to the ones that are producing power, etc. And if you are performing under that threshold, then you can generate credits, and those credits are worth, the dollar of carbon pricing. So today it is around $40 a ton. So for every ton of CO2 you're below that threshold, you can generate those emission performance credits. Similarly, if you're performing above, then you have to pay into that compliance requirement. Or if you had some banked, you can use those credits to be in compliance. So there is that structure, and it's one that is fairly consolidated here in Alberta. At the federal level and nationally, what we call is the OBPS, the output-based pricing system, which is similar, and it's all based on the proposed carbon tax that we've heard of, and to reach $170 by 2030. So that will be one that helps us fund a portion of the very high capex intensive projects like the carbon capture. So those we would rely on them, and it's required. But again, the question is, if you don't do a carbon capture, you're going to have to pay those $170, right? So it is an incentive for you to do it, because then you get in some benefit. It might not pay the whole project, especially on the capex side, but it certainly helps with that.
Give me an idea of how then you're looking at that $170 per ton. Is that a price that's just too high for a company to pay? Are they wrong on the target on that? Does it need to be higher than that? Would you be motivated to make the changes that you are at a lower price? It's always sort of tricky to figure out what the appropriate price is, and I think people are quite concerned that the price is set so high that it's going to put industry at a disadvantage. I'm not hearing that from you, but that's why I'm kind of wondering how you're assessing that price.
Well, I think the question comes in two ways. First is just to look at the carbon price tag. I think it's more importantly to look at the threshold, the intensiveness of your emissions. I think that's important, because that needs to be placed in a level that is doable. Because the price level, logically and naturally has to be increasing. Otherwise, people will be just conformant and just stagnant, and there won't be any incentive for you to improve or reduce your emissions. The question is, again, are those targets and thresholds to be in compliance set at the right level? And then the stringency of those and the evolution of time, are those going to be evolving ever so fast or faster in the time frame?
All right, let me, I want to just deal with a couple more issues to understand a little bit more about how you got the corporate change in your company, because it sounds like it's been quite a bit of change in the last 5 years, and certainly with 2019 being identified as a target for when you made some major changes. Trevor, let me just put it to you, because I know that there are still a certain portion of the public, certain portion of Albertans, certain portion of business owners who are looking at this saying, do we really need to do this? Is this the right way to go? Is the urgency there? Do we need to move this fast? Does it need to be this expensive? Do I really have to change? Everybody is resistant to change. I'm just wondering how in your company that kind of got overcome. It sounds, if I'm hearing what you're saying, it almost sounds like once you were able to make the value proposition that this is what customers want, we can be leaders and we can get a benefit by being first to market. That seems like it gets you a lot of the way there, but is there anything else that we need to be factoring into consideration for those who are kind of resistant to the way the world's moving?
Well, I think there's an old saying, and I'm going to paraphrase it poorly, but it's, the optimist believes the wind will change. The pessimist believes it's going to blow the wrong way, and leaders adjust the sails, right? So if you look at which way the wind is blowing, you have to adjust the sails to adjust your sails to adapt, right? And the Paris Agreement is in place. We've just in the last 2 months had the federal government come out and double down on some of those commitments. We know where the price of carbon is going. The Supreme Court challenges are in, and they're essentially, from my understanding, settled. So it's time to adapt. I don't think I'm the right person to comment on right or wrong. What I would say is that we need to make sure the playing field is level for all participants, right? And so in our industry, one of the things that we are acutely aware of is, cement is a global product. What Ignacio's group produces is a global product. Mine is much more local, but cement can be manufactured anywhere and shipped anywhere for use. And we've just got to make sure that cement that might be imported into Canada is subjected to the same, either some sort of tariff system that would put it on the same playing field, because it does us no good if it's produced using coal in offshore, shipped into Canada, trucked all the way up into Alberta, and it arrives here with a higher carbon content, but the producers are able to sell it here cheaper because they weren't subject to the same carbon pricing. So that's an important consideration for our industry, and one that I think that needs to be addressed across all industries, and everybody that's in the manufacturing industry in Canada is worried about that, and just making sure that the playing field does not put us at a disadvantage versus offshore or out of country production.
It's a good point, because even William Nordhaus, who everybody quotes, is saying, because he won the Nobel Prize on carbon pricing, that was one of the points that he raised, is that if you have your own price, then there has to be some kind of adjustment to make sure that all the products coming in are competing on the same playing field. So I don't know, if Ignacio, if you have any thought on that. It almost sounds like the way that you're creating that declaration, so that people know what the amount of CO2 is per kilogram or per cubic meter, that may go a long way towards figuring out whether we're having comparable products and comparable pricing. Do you have some thought on how you can make sure that field stays level?
Yeah, and I think that's something, it's a conversation we're having ongoing today, which is the carbon, what they define as carbon leakage. And it's exactly what Trevor and yourself were talking about. And the one thing that we're trying to do is also these EPD documents are based on a protocol based in North America. What we're trying to do is make sure those EPD documents are in compliance or adjusted to also meet globally. So that when you have an EPD and you're importing a cement, well, your EPD has to reflect the footprint to make it where the source, and also the shipping of the whole freight and anything else related to it. So we're trying to make sure that the policies in place account for and control, more importantly, carbon leakage. And the way to do that is sometimes make sure that the impact is measured through EPDs, so then that consumers will buy one or the other, and it will reflect exactly what's in the product.
Let me then back up one more step as we're getting sort of to the end of our conversation here, because I think there's a real feel, and I'd love for you to correct this if I'm incorrect. There does seem to be a sense that Canada has a number of additional costs being imposed on it that we're not seeing in other jurisdictions, and we're not going to be able to compete. And I recognize that this area does need to be addressed, but maybe, Trevor, let me ask you, like, what is the environment like for the creation of cement and development of concrete in Canada? I mean, do we have some kind of comparative advantage relative to our competitors, or are we in danger of losing ground?
Well, again, when it comes to concrete, hyper local, you can ship cement globally, but once I add water and cement and rocks and sand in the back of a mixer truck, I've only got a couple hours till I have to have that unloaded, or it's just a really hard rock inside the mixer drum, right? So in terms of whether or not we're at a disadvantage, we really have to look at the cement industry. And again, I'd probably just throw that over to Ignacio, but we just need to ensure that we are on a competitive playing field wherever we are, both whether we're bringing in offshore production or U.S. production into Canada, or whether Canadian producers are trying to export product and sell into markets that don't have those same, that might not have the same carbon pricing. And that's the key. And where it sits right now, we're concerned that there certainly is some disadvantages built into the system for us. And we're just hopeful, we work through our industry associations to advocate and lobby that we need the federal pricing system to be flexible enough to allow us to compete.
Do you have any other issues that you face in your supply chain and getting the different components that you need for concrete? I guess I'm just conscious of the fact that every time I talk to somebody in the construction business, I keep hearing about price escalation or shortages, whether it's steel or whether it's, 60 to 200% increases in lumber. Are we seeing the same thing in concrete? Are there some supply chain issues that you're concerned about?
Well, I mean, one of the nice things about concrete is it's actually most of the products for it are produced local. So it's one of those things that when you buy it, there's a very good chance that, somebody on your block or your neighbors had a hand in that production. So the sand and rock that we use as the other major component, it's always extracted locally. It's not something that's brought in from long distances, so it's not necessarily subject to the same global commodity fluctuations. Certainly, there's local demand changes that dictate pricing and whatnot. The cement manufacturing facility that Lehigh has. It's a world-class facility that everybody drives by every day in Edmonton, even though they might not know it. It's right on the north side of the Yellowhead between 156th Street and 170th Street. So people have been going by it for decades, sometimes not knowing what that is. But everything's produced locally with local labor, local materials, etc. On the concrete side of things, it's like most of my, I won't say all, but 99% of my inputs are local, with the exception of the production and delivery equipment, which is often manufactured, parts and supply is manufactured either in Eastern Canada or the United States. And demand for those parts can really drive up our input costs. Like right now, it's getting very difficult for us to procure new drums for mixer trucks, for example, just because of the demand for steel right now, and not even the demand, but some of the supply chain shortages that we've seen since COVID. Certainly impacting some of our pricing in terms of our equipment fixed costs and our CapEx costs, but in terms of the raw material inputs, not so much because we are so local.
So if I wanted to pour, I'm just saying, just blue skying here, if I needed to pour a new sidewalk outside my house, would this be a good year to do it? Because I don't think it's a good year to build a deck or a fence based on the increase in lumber prices. Am I facing massive cost escalation, or has it been pretty stable? I'm hearing you say it's pretty stable.
Yeah, it's relatively stable. I mean, it's comparatively and relatively stable. I mean, certainly we're under the same inflationary pressures that others are for both wages and some of our inputs, diesel costs. Like I said, even just trucks for parts. Demand is really high right now as well, as we see the residential sector all across Canada and Alberta included just be exceptionally high demand. So that's impacting pricing. But whereas you will see steel and lumber pricing. I mean, we've seen lumber pricing triple or quadruple for certain types of lumber products. It's not unusual to see steel prices increase or decrease by 50% in a 12-month time span. Concrete's a much more stable price-wise. We certainly have seen some what we would consider significant increases in pricing, but those are in the neighborhood of again, we're talking single or low double-digit increases, and not 50, not 100% or 200% increases.
Okay, thank you for that.
For that sidewalk.
Okay, I'm going to. Thank you. I was really worried that I might be better off if I waited a couple of years, but boy, it really needs it. So then with concrete being sort of a local market, and Trevor mapping that out for us about what the price factors are there, what's happening in the international market, Ignacio, for cement, and how does Canada compare when we're looking at our major competitors? I don't even know what percentage of the market share Canadian production has. Can you map that out a little bit for us and tell us whether it's a growth industry?
For sure. I mean, just to give you an idea, in Canada, we have around 16 to 19 cement plants. For instance, Heidelberg group worldwide has 160 cement plants, and we know that there's a market that is growing in demand, because quite frankly, they're saying there's some statistics that came from Architecture 2030, which say that by 2030 there will be a new New York City built every year.
Oh.
And it's quite amazing because of all the demand growth, and it's coming from other markets, not necessarily North America or Canada, but other developing countries and developing economies. So they will be, and that's the challenge, Danielle. The biggest challenge is we're addressing the emissions, but we're addressing the emissions on a market and in a product that is growing in demand.
Yeah.
So not only that we need to address it today with the demand that we see today, we need to account for the volume increases that are happening in the future throughout globally, and that's the biggest challenge.
All right. Let's then maybe wrap it up with some final comments from you about how you think that Canada needs to move forward on some of the issues that we've been talking about. I think as we're sort of getting out of the COVID era and we're sort of thinking about what life looks like post-COVID, give me your sense, Trevor, if there's anything that governments need to be considering for policy changes or priorities, or is this industry just sort of set to take off?
Yeah, I think there actually is a few things. We touched on the importance of transparency. Ignacio mentioned it a couple of times in that, sometimes just the math never lies is one of the things I like to say. And so when we look at EPDs as kind of that carbon nutrition label, we need to look at the entire life cycle of a building when we're judging what materials are best suited for that. It's not just enough to say, well, this piece of wood has, this wood beam has less carbon intensity than the concrete does. Well, let's actually look at the EPD. Because does that actually bear it out? What is the life cycle of both products comparative to each other? And those are going to be iterative processes as people get more sophisticated in accounting for carbon. A lot of it can get lost in the spin right now. There's a lot of greenwashing going on out there from various products, and that's one thing that Lehigh and Ignacio will back me up on this. We're very, very adamant that we're not going to greenwash. We want to talk about the math, and we want to have honest conversations about what that looks like. So in terms of public procurement, private procurement, and policy level for the public procurement policy, we've got to make sure that our governments are educated and the procurement departments are educated to do the math properly and not get lost in the spin. Because there's, one of the things we see out there right now is people want to do the right thing. End user consumers, public or private, they want to do the right thing. But in many cases, they get lost in the greenwash spin. And so we think it's one of our responsibilities to help educate the public in how to do the math with those EPDs and those carbon nutrition labels, and talk about cradle to grave carbon intensity from both embodied, operational, and then disposal or recycling. So that would be one part of it that I think is really important. So just an education on the carbon accounting that we want to help drive. And then secondarily, just what I've talked about before, making sure that particularly for our cement commodities, that we are not disadvantaged when either competing domestically against imports, or if we're competing outside of Canada against other producers in other jurisdictions. Those would be the two priorities that I would say for us.
Those are excellent. Thank you so much for that. And Ignacio, are there any policy priorities at the either provincial or federal or even local level that we need to be addressing just to make sure that we're removing barriers?
First of all, there's a couple of things. I would echo what Trevor said. Very truthfully, I think there's a couple of things that we need to make sure the government is helping us push, and that's policy towards getting compliance requirements on building codes. Right now, everything that we are seeing is voluntarily or driven by a city, but it's not necessarily part of the building code. So until we don't see this part of the building code, the adoption rate is going to be very limited. And we mentioned the sensitivity around the time of embodied carbon, and that's why we need to make sure that policies are created to push this sooner than later.
I'm not sure whose computer that one is. Might be, we've got something going on in the background. That was like a
Yeah.
flourish to what you had to say, Ignacio. I almost feel like I should end there, but before I do, I should ask one final question because I'm quite concerned about making sure that we've got enough people getting trained in the areas that need to be trained for our growing industries. And I wonder, Trevor, if you've got some thoughts on that. Seems to me like we're going to be creating a future industry for accountants to be accounting for the different types of carbon sequestration in different building materials. So for those white collar workers who want to crunch the numbers, it looks like we've got at least a few new occupations emerging in that field. But give me a sense from on the ground. What kind of labor shortages do you think we might be facing?
Well, certainly a couple. One of the big opportunities, I think, for people coming into our industry is just the technical and engineering side of things. So as we continue to find innovative ways to use new raw materials or more advanced raw materials to drive down the carbon intensity of our concrete, we've really invested in our company, both locally and within the rest of the region, in a lot of engineering. So we brought on a lot of, we've started a trainee program for young engineers coming into the company because we realize that skill set, that research and development skill set, is becoming more important to us. I think there was a time where we saw that as kind of we used to be seen as a more traditional industry that didn't really have a lot of new products or a lot of engineering and research needs, and that's really flipped on its head, I would say, in the last 5 years in our entire company. So we're bringing in a lot of that talent and a lot more into our labs and our engineering labs to try and design lower carbon, higher performance products. So that would be one. The other one too is we are in a bit of a building boom here in Alberta and in Canada in general. It's I think it was a surprise to everybody coming out of COVID or still being in COVID, and that's driven labor demand for all sorts of people, whether it's blue collar workers and truck drivers, right up through engineering and quality control personnel. But yeah, I mean, I think the big opportunities is for innovative, educated young folks to come into our group and participate in designing new product.
Awesome. Anything to add to that, Ignacio, about what future opportunities there might be and demand?
I can certainly say that the importance of all the investment we're creating, it shouldn't be looked at only from the lens of the environment. The fact that this is going to be an economic multiplier, creating jobs. We've seen huge numbers, over 1,700 direct, indirect, and induced jobs as a result of projects like the carbon capture and storage. So this is creating, as you mentioned, a different industry. And we're, we sometimes laugh and joke around this, but in addition to having sales teams, in the future, we might have to have cement and then carbon dioxide sales team, because carbon dioxide is not going to be a byproduct anymore. It's not going to be a waste product anymore. It's going to be a commodity that provides value.
I can't wait to see how you develop that side of your business, and we'll have to have you back on again as you continue to develop it out. Thank you both so much for your time today.
Thanks for having us, Danielle. Pleasure to talk about what's happening in both our company and our industry. So we're glad to have been here.
Oh, my pleasure.
It's always an excellent opportunity in people, the difference between cement and concrete.
I know, I still screw it up. I'm going to try not to. Thank you both so much again for your time today. That was Ignacio Cartiera, who is the technical marketing manager for the cement division, and Trevor Panas, who is the manager of Northern Alberta for the concrete division of Lehigh Hansen. And as you heard, I think they take pride in the fact that they're industry leaders on this front. And this is what I would say, just in closing, maybe where we began, is the notion of being able to do the full cost accounting so that we're comparing our industries appropriately. I think that's an important thought to us carrying over onto the discussion of energy production also. It's sort of where I began. But the fact of the matter is that it doesn't seem to matter where I go, what industry I'm looking at. There are entrepreneurs who are taking on this challenge and I think are going to address it. So have some confidence. I know that we're all frustrated whenever we see new taxes or new regulations, but I would never bet against entrepreneurs, especially entrepreneurs in this province. I am Danielle Smith. I'm president of the Alberta Enterprise Group. We will do this again next week. Make sure you join us then. Thanks for tuning in.